Hey everybody, welcome back. At this time, we will be checking or we will be testing our humidity sensor that we have created by using IBC548 transistor, right? Then the first part is to confirm that it's working. Here we have water and we have our basic circuit. So here we are going to introduce, oh my goodness, it is working because it has detect water, right? Then how does it work? What is the science? What is the robotics behind this? So do you want to know more? Let's hit the ground running. So the first part that we gotta recall is this, right? Let me please move this. So later we are going to continue with this, okay? So let's check or let's read this circuit first, right? The first part of this circuit is pretty easy to understand. It's a piece of cake, right? Here we have the basic circuit. Here we have a 1 kilo resistance. You gotta recall that that all resistance or the resistance by itself doesn't have a polarity, right? But here we have a LED, and LED really have a polarity, right? I can define like a LED, like a resistance that has polarity because the LED is working to protect, right? LED is shining, but also is protecting the circuit, okay? And also, if the current will flow in the inverse way, the LED won't allow this. That's why if you connect the the LED or the diode, it is called diode. LED equal diode, right? That LED will protect the circuit and won't allow to electricity to flow, right? Then that's why the energy starts here, start reducing, right? It is reducing now. It is getting, it is getting, it is coming into the positive path, right? Here we are collecting the energy. That's why the LED is working here, right? So here, if you check this, we have this diagram. Perhaps that's new for you, but if you check the data sheet, what is the data sheet, teacher? The data sheet is the public document that there's or that exists that is showing all the electronic uh, features that your device does have, right? Then the data sheet, you will have the voltage, the current, the maximum temperature, the emitter base voltage. Then you can have a lot information about the component, right? So here, if you check here, the meaning of this is 1, 2, 3, because pins, this resistor, it has 3 pins, right? It does have 3 pins. The first, second, and third, right? Start counting starting by left, okay? Now here, this is the pins distribution is the same. If I read this 1, 2, 3, then this is the capacitor, right? The capacitor does have 3 pins here, as you can check here. 3 pins, right? 1, 2, 3, right? 1, 2, 3. Also, you gotta recall that this has a circle surface and a flatter surface, right? This is the pin number 1, this is the pin number 2, and this is the pin number 1, 2, 3. Okay, let's keep working. So we are analyzing the diagram, right? Now The circuit is staying, please, positive and negative turn. It's collecting here, and we are connecting this with a resistance to a capacitor, right? This capacitor is the 104, 104, okay? This is the third, and it is connected to the another pin of this capacitor, right? Then you're connected at 2 and 3 at the same time, right? So the sequence is pretty easy to understand, right? Here you are storing energy to avoid peaks. Here you are acting like a switch, okay? You are acting here like a switch, and the resistance are made or were put at there to protect the circuit, right? What is about the Ohm's law? The Ohm's law is saying that the current is equal voltage divided resistance. E is equal intensity equal current. The current is amperes, right? The current measurement is ampere. Et tu dois parler français, ampere, monsieur. Okay? The voltage measure is volts, and the resistance measures, and the voltage is volts, and the resistance measure is ohms, right? Here, I can confirm, or I can state that if I divide the voltage divided the resistance, I'm going to get the intensity. This is pretty easy to understand, right? So what do I have to understand about this? Let me please continue with this. Here we have this basic example, right? You have the voltage. The voltage is 5 volts. You have the resistance, and the resistance is 2 ohms, right? What's the current? The current equal 5 volts divided 2 ohms. It's equal 2.5 amperes. It's a piece of cake. You just had to divide, right? Then that's all. That's the exercise. That's how you can use this concept of Ohm's law to get the current, right? Then let's check more. Let's have another examples. Check this another example. Now at this time we have the current, voltage, and resistance. We have three different equations, but based on the same equation, right? There are some derivations. If I need to get the resistance, or to find out the resistance, we have to divide the voltage divided the current, right? Then resistance here, the voltage 5, current 2.5, resistance equal 5 divided 5 equal 2 ohms, right? It's just a division. It's a simple division. Let's continue. Now in this exercise, we don't have the voltage, right? We have the current 10 amperes, the resistance 3 ohms. Recall, voltage equal intensity multiplied by resistance. 10 multiplied by 3 is equal 30, right? 30 volts. That's all. That's this concept. That is pretty easy to understand. You just have to memorize this. Okay? Then now let's move it on. Now, this is the concept that we have to have clear. First concept, parallel. In parallel, voltage is the same. Okay? Parallel. In parallel, the voltage is the same. In serial, current is the same. The BC 588, 48 acts like amplifier, reducer, and a switcher. This is a transistor, right? And transistor. LED is like a resistance with polarity that breaks. Okay? Also, we can state that the resistance main function is to protect circuits because of Ohm's law. because here this equation is saying more resistance, less current, because the proportion here is inverse, right? This is a direct and this is an inverse, right? More resistance, less current. That's why the another one is more current, less resistance, right? So that's the main point of this, okay? You already know what you gotta do. You gotta write this down. You gotta go and go over and over again, right? If you got some question, please don't hesitate to stay then on the comments below. I will be more than glad to help you out. So see you in the next video that I'm going to show you how to create this amazing circuit to be working, okay? So see you in the next video, and if you got some question, don't hesitate to ask them on the comments below. See you.